Welcome. Okay. Now we get to do the other piece, which is on the negative side. Okay. So we're going to practice using the definition again. Okay. So here, I wish you understand. All right. What we have done so far is just exploring the definition, right? So definition is like the gold mine in trigonometry. It's the gold mine. All of these, right? All of these points we have digged out of definition. Okay. ARD, right? A, angle measurement, right? We have the arc length for input and the ratio for sine, which is in the definition, right? Reference angle we use often, right? In the process of making the points. And now, as promised by the previous video, we're going to work the other side. Okay, both sides are needed because you're going to see very soon. On the other side, we have done all of these points, right? In the video before the last. And now for this picture, right? We're gonna we keep the 0, 0, right? So I'm gonna delete the rest of them, and I'm gonna delete all of these, okay? So as I delete, right, you can see which one is gone, right? Which one is gone, right? There. And the other side will be done the same way, completely the same way. However, I wish you guys get used to how to, right? How to work with the negative angles, okay? The negative angles. The negative angles are measured by clockwise measurement, right? It's still within the definition. It's still within definition. So clockwise measurement. Okay, so let's try that. And this is the part that I have seen no textbook have done it. Okay, in detail. Is it important? Yes. Okay, you will see some of these pieces are absolutely important for us to understand. Now, without further ado, 0, 0, right? We're done 0, 0, no problem. So this piece we're gonna do is from 0 to negative 2 pi, negative 2 pi right here, okay? So we're gonna do this piece. So once again, it's a quadrant by quadrant, but this time is a quadrant 4, quadrant 3, quadrant 2, and quadrant 1. Why is that? Because we're going from this piece, okay? So the first quadrant, the first point, right? Suppose we use these special angles to make it easier for us, right? So the first one, we measure negative pi over 6, negative pi over 6, right? So I'm going to write it down. Sine, okay, sine, you also need to know how to write it mathematically, right? Negative pi over 6. Oops, my bad. Negative pi over 6. Pi over 6 is equal to negative half. That's how we write it down. Okay, input, output, right? Same way as our other functions, same way as our other functions. Negative pi over 6 is the input and negative half is the output. So on the unit circle, what do we do? On the unit circle, what do we do? Well, we're gonna measure from the standard position clockwise. You see, we're still doing ARD. We're still doing ARD, right? Standard position ARD, and terminates terminates right here. Okay, this is a terminal. The terminal crosses the unit circle. And since we're dealing with sine, so it's a negative half. It's a negative half. Okay, so what are we going to do about that golden piece, arc length? Once again, the arc length, I'm going to draw that golden piece, okay? Because this way it's measured, it's counted as negative pi over 6, okay? So this piece is negative pi over 6. And that piece is going to be negative pi over 6, okay? And the ratio is a blue number, negative half. So the arc length or the radian angle, right? Radian angle has the same value as the arc length on the unit circle, okay? So now let's mark the point. Negative pi over 6, okay? And the ratio is negative half. Okay, you can see the blue dot show up, right? And we're gonna label that. All right, now the gold piece, right? The gold arc length, right? Or radian, okay? Negative pi over 6, why negative? Because it's measured clockwise. And the blue is the ratio. So we basically do this, right? Quadrant by quadrant by quadrant by quadrant. Will I quiz you? Absolutely. Okay, so now the same drill, just negative side. So let's do it together. Okay? So I'm gonna clear the drawing. Maybe I'll just keep it I'll keep it for a while, okay? I'll just keep it a little bit longer, okay? I'm gonna stop the labeling. Well, let's not stop the labeling, okay? We'll label as many as we want, as we can, as far as it is clear, okay? So let's do the next point. The next point, of course, is going to be negative pi over 4, not a 7 pi over 4. Some of you can see the 7 pi over 4, because we're going to measure negative pi over 4, right? Negative pi over 4. So negative pi over 4, and the ratio is negative root 2 divided by 2. Okay, so that's a green dot. See the green dot? Right there. Same meaning, okay? Arc length, okay, measured clockwise from the standard position and the sine ratio. So you please mark that point with negative pi over 4, comma, negative root 2 over 2, because I always want the precise value, as you know. Okay, so keep going. Okay, if you're next to a computer, you can do this on computer. So the next point is negative pi over 3. Negative pi over 3, and the ratio is a negative square root of 3 over 2. Divided by 2, sorry. Divided by 2. I'm a little bit excited, okay? Because we're going to get this done and you're going to see so much more, okay, labeled, okay, right there. Next is negative pi over 2, not 3 pi over 2, because we're measuring the angle clockwise, right? All of these is about the negative side, okay? So negative pi over 2, and the output is -1. The blue number is -1. There. Okay, so black dot, you can see the color coordination. And I think so far, the showing seemed to be rather clear, isn't it? Okay. All right. If it's not clear, we're gonna go backward, delete, so you can see it, and you can play it by yourself. Okay, so first, the fourth number 4, quadrant 4 is done. Quadrant 4 is done. So let's keep going. Negative, what would that be? -2 pi over 3. Okay, -2 pi over 3. Okay, if necessary, I will make a session to do degree and radian conversion. Okay, but now you just think of this is going to be -2 pi over 3. Okay, this is a +2 pi over 3. See how that's how I figure out, right? And this is a -2 pi over 3, right? -2 pi over 3. So for -2 pi over 3, 2 pi over 3, and the ratio is a negative square root of 3 over 2. Okay, the red dot marked. Okay, so mark this red dot by this guy. Okay. Okay, so I'm going to keep going. Mark it by this point. Okay, and keep going. The next one is going to be -3 pi over 4. Okay, you see, this is a +3 pi over 4. Okay, so let me mark it so you can see. Okay, you can see how I do it. Okay, there's really there's not much to trick. There's not much to trick. Okay, how do I decide this this measurement, right, from the standard position to this terminal here, right? You know where we're going. It's not a 5 pi over 4, if you can see that clearly. It's going to be -3 pi over 4. So since we know the +3 pi over 4 on this side, right? So +3 pi over 4, right? So this piece is -3 pi over 4, if that makes sense to you. Okay, so that's -3 pi over 4. Got it? So let me clear this and do it again, because I want to have that perfect as possible. Okay, -3 pi over 4. -3 pi over 4. I don't think I can ever make it perfect, but you forgive me. I forgive myself. That's -3 pi over 4. Clockwise. You see, we're still working on ARD, right? ARD. With that done, we have the blue number here, -√2 over 2. So we're going to put that point in place. Okay, -3 pi over 4, -√2 over 2. Yay, there we go. A blue point right here. Okay, right there. And next, of course, is going to be -5 pi over 6. The next one is -5 pi over 6, right? So you got it, -5 pi over 6. So -5 pi over 6, and the ratio is -½ There we go, labeled. It's green. Look at that green dot. Okay, mark this point on your notebook. Okay, and you can follow my instruction. You'll be completely a master of this, how to plot these points. Okay, and next is -pi, of course, right? Keep going, right? And we're gonna get -pi. Boom. And what is that blue number? 0. Right, so -pi, comma 0. Okay, -pi, comma 0. It's right there. It's a purple. And what is that pi? Right? it's this much is pi, half a circle, half the unit circle in circumference, okay? Half of the unit circle, right? There we go. And at that, the 0. See? So the rest is just a practice. The rest is really just practice, but let's keep practicing, okay? And we keep going, and this is gonna be what? What is this is gonna be? If we continue to, from standard position, keep going to where? Negative 7 pi over 6, right? Because this piece is positive 7 pi over 6, which is measured this way. So this way is negative 7 pi over 6, right? So negative 7 pi over 6. In the process, okay, if you pause at any moment, you're going to discover so many interesting things, right? And you never have to memorize a lot of things, okay, because we have more things to come, okay, more things to observe. This is a gold mine, yes. So this is a negative 7 pi over 6. Okay, so now we're in the second quadrant. What is the blue number? Positive, yes, positive. Okay, positive. What is that dot? Where's that dot? No, 7 pi over 6, I marked it wrong, okay? Negative 7 pi over 6, right? When I missed that 7, you see what happened? It moved to the wrong place, right? All right, there we go. Excuse me. So now, negative 7 pi over 6, half. There we go. Keep going, okay? Keep going. I also want you to look left, right, and compare, right? And I have limited space here, but I want to show you, right, one thing at a time. So, and we keep measuring. The next arc length is going to be negative what? 5 pi over 4. This is a negative 5 pi over 4, okay? Negative 5 pi over 4. Do the conversion if you want. Pause the video if you wish, right? Negative 5 pi over 4. Isn't this fun? Isn't this fun? And this is root 2. The blue number is positive divided by 2. Okay. This is so easy to do, isn't it? Has it become easier? I hope so. Okay. As it's so easy to do, and you have so much connections, and there are a lot of things will come to you without having to memorize. Okay. So now we got a negative 5 pi over 4, right? Root 2 over 2. And we just keep going. Just keep chugging forward, right? Chugging forward. Okay. So we are here, right? And the blue line, the blue, right? Don't forget the blue. There's lots of blues, right? So this is the blue, right? For negative 5 pi over 4. You see, the meaning is completely consistent from beginning to end, and no exception, and for eternity. Isn't that marvelous? Isn't that amazing? Well, at least that's how I feel, okay? And we keep going, okay? The next one is going to be negative 4 pi over 3, okay? How do I find out? There's a 4 pi over 3 there, right? So or you just keep going, because this is going to be, you can figure out, right? 360 minus 120. So you can just figure out. There's so many ways to figure out, right? So if we measure the next angle terminates here clockwise, there, right? That arc length is going to be longer. Longer, right? It's going that way. And that angle, and you see the blue number? You see the blue number? Yep, you guessed it, right? So this is a negative 4 pi over 3. Negative 4 pi over 3, comma, positive square root. Okay, there's a negative. A negative sign there, and And the ratio, the blue number, is √3/2. There. You see the blue dot show up right there. Boom. Boom, right? And then we can extend the orange from here over there, and the blue bar just keep going, right? And next is -3π/2. -3π/2. -3π/2 is going to go all the way from the standard position, measure clockwise, all the way, get here. You see, I'm constantly on angle measurement, reference angle, and definition. That's all I do. That's all we do. We've been repeatedly doing this to making how many points? How many points? Many, many points, right? Many, many points. So the definition is the focus. ARD is the centerpiece. That's the guiding principle. Isn't that a gold mine or what? Right? So the next point, we're going to reach the highest point. We're going to reach the highest point. See, we can reach the highest point from the other direction. Okay, so there we go. Where is it? The green dot, right? Where's my green dot? You see, I made a mistake because it should be +1. I put a -1, right? There we go, +1, right? Because the green dot, the blue number is on the top, the way we measure it, right? What did I do? I put a -1, right? I made a mistake like that, right? There we go. So we have to be very careful, okay? Now, well, I make mistakes, like every one of you, I assume, right? We all make mistakes, right? But the most amazing thing, most rewarding thing is that we can identify our mistakes and correct it, okay? So next one. The next one will be -5π/3, -5π/3, okay? -5π/3, -5π/3, and what is that ratio? The blue number, right? The blue number. So it keeps going. It keeps going. This is -5π/3, okay? -5π/3. -5π/3. And what is the ratio? The ratio is √3/2, the blue number. The blue number, okay? √3/2. There we go. This time I did not make a terrible mistake. Excuse me. Okay, now, okay, we got a purple number, yay, okay? We're close to the end, but not really to the end, okay? I want you guys to think and make connections, to get those, get really sticky into your mind. And we're really just using definition all day long, right? We're using definition all day long. Let's go. Okay, let's keep going, okay? There. So now this is the -7π/4. This is a -7π/4 right there. Okay, it was 7π/4 counterclockwise. Now this is a clockwise, -7π/4. Okay, so -7π/4, -7π/4, comma, √2/2. √2/2. Okay, label it. You see that dot, the black dot, which corresponds to the color. Okay, 2 more. There we go. Keep going. Okay, so the next one, we're gonna go here, right? From the standard position, clockwise measurement, right? So the clockwise measurement, with an arrow would be helpful, right? The next one is -11π/6. negative 11 pi over 6, okay? So with negative 11 pi over 6, the ratio is half. Negative 11 pi over 6, comma, half. You see the red dot? You see the red dot show up, label, boom, right? One more, the last one. Negative 2 pi, negative 2 pi, okay? The whole circle, circumference, okay? Negative 2 pi, because we measured clockwise, that's why it becomes negative 2 pi, okay? And we straighten it up. We straighten it up, straight. Okay, so this length is negative 2 pi to the left of y-axis. You see, everything was very clear, agrees with our, arrangement since beginning algebra, since the rectangular system first introduced to us, right? Consistent. And it's going to be this way when you're going through your calculus classes. Okay, calculus 3, you just add another dimension. Okay, so 0, that blue number is 0. Right there, 0, label it. So this is the full circle from the clockwise. Okay, so now we got something interesting, right? I want you guys to really remember. So we're going to just wrap it up on this section, but there's other things I'm going to address, like one-to-one functions and so on and so forth, right? Increasing, decreasing, right? We're going to get to those, narratives. This is a story. We're telling a story, okay? So I'm going to take away the point, right? The blue, we're going to remove that label, so you know that what that is, right? I put the label back. I'm going to remove, hold on, I'm going to remove this guy, remove the red dot, right? You already know that. So that's the red dot. The expression is still here, right? So that red dot is right here. That's how you mark it, right? And you keep going, okay? Negative 7 pi over 4, which is this point, the black. Show it like that. So you guys can play with it any way you want, any way you want, okay? You can also take a picture of it. You can also take a picture of it, right? And yeah, so we got these points. We got these points. I'm saving the negative 3 pi over 2, right? And 4 pi over 3, I'm going to take that off. Negative 5 pi over 4, I'm going to take that away. And negative 7 pi over 4. It really, you can just play with it. Excuse me, negative pi right there. So if you have done all of these, okay, I don't know, you're going to be so good. You're going to be so good at this. And maybe you're going to teach me one or two things, right? You see how easy it is to do and how easy it is not to do, isn't it? Easy to do and easy not to do. Now, we're not done yet. We're not done yet, okay? Because there's other things I like to discuss with you, right? When we were discussing those other functions, right? So now I'm going to bring them back. So we got the unit circle here, right? And we got this guy here. And what I'm going to do is that, remember the horizontal line test? Right? We already mentioned that this is not a one-to-one function, right? This is not a one-to-one function. And what else there is, right? It's not a one-to-one function. Is it increasing? It seems that it increases from negative 2 pi to here, increases from negative 2 pi to negative 3 pi over 2, decreases, decreases, increase, increase, decrease, and so on and so forth. You see, the sine curve is increasing, decreasing, alternating, increasing, decreasing, right? Now you go back to see the definition of increasing function, decreasing function again. It's always referring to specific intervals. So what is our narrative, right? What is our narrative? Okay, so now I'm going to give you the narrative about increasing and decreasing, okay? I'm going to put this away, okay, temporarily. No, I'm going to keep it here, all right? And I'm also going to, because I need to use that screen. I need to use this screen, okay? So this is what I'm going to do. Okay, so I'm going to give you some examples of how to describe increasing, decreasing, using the word in mathematics. Okay, so we have these here, right? And I'm just going to make a little bit of adjustment, right? So you see these points, right? You have seen these points. I'm going to add some points. I'm going to add the points back when we did it, when we did those other things, right? So I'm going to add the points between the other from 0 to 2 pi. Remember we did those, right? From 0 to pi, I'm only going to add a couple points. Okay, we have 0, 0. I'm going to have pi over 2, comma 1. We did all of these, right? The dot. I'm going to add a pi 0, right? Pi comma 0, right? That dot, purple, labeled. And you see they're so consistent. Don't you love them? 3 pi over 2, right? And this is going to be -1 as output. And I'm going to show you how we're going to describe increasing, decreasing function, okay? So this is going to be, what is the language of mathematics that you can write down and then to get the points you need. And you need this practice, right? You need this practice, okay? When you're in calculus class, oh yeah, you do, okay? So now I'm going to show you this piece of picture, right? So now we can tell the intervals, right? From this interval to here, that's increasing, decreasing. How do we say that, right? So that's what we're going to get to. Okay, so I have my, you know, whatever type setting I have, right? So I'm going to write it down. The description using math language about increasing and decreasing. Okay, then you can say sine, okay, sine x is increasing. Okay, we can use any example, right? From -2 pi to from -2 pi to pi to -3 pi over 2. Now, I want you to compare this with the definition on your flashcard. What's the definition of increasing function? Could you do that, please? In a lot of situations, actually, you can also use open interval. You can use open interval, okay? It can be open. Doesn't matter, open or closed, as long as the definition works there, okay? And another example, we can say sine x is decreasing in where? There's so many examples, right? I can say from 2 pi, because increasing the interval is describing the input, okay, from pi over 2 to 3 pi over 2. So this piece is decreasing. Do you see that? This piece is decreasing. So you can say open interval, you know, or not, right? It's from pi over 2 to 3 pi over 2. Right? This is how you say it. This is how you say it. In the future classes, say for example your calculus classes, right? You're gonna have other different functions. You're gonna have to figure out where increases, where decreases, and highest point, lowest point, and that's the language you use. This is the words you need to use. So sine is increasing. Sometimes you can even get away using a symbol for increasing. Increasing symbol sometimes is using that one, okay? And decreasing, we use the other symbol, there, right? You can see, you can even save the word. You can even save the word, right? Which is, these are the shorthand notation. You can see sine increases in this interval, right? Sine decreases in that interval. So if you talk about saving words, not having to write so much, you got it, right? Very, you know, picture graphic. Another interval I like to show you is this piece between negative pi over 2 to pi over 2. This interval is of particular interest. Okay, this interval is of particular interest. Okay, in the future, we're going to come back here for good reason. Okay, I want you to remember this. The horizontal span, okay, is between negative pi over 2 to pi over 2. The vertical span, so we have a horizontal span. Okay, so this is my horizontal span. Okay, and there's a vertical span, which is the blue. Okay, between -1 to +1. This piece of graph, okay, so if I put a box about it, let's see if I can do that. Okay, if I put a box about it, right, this piece will be of very specific interest to us. Okay, this piece will be of very specific interest to us. And is sine function increasing or decreasing in this interval? What do you say? Well, sine function is what? Is increasing in this interval. We call it negative pi over 2 to pi over 2. I want you to write those down. Okay, these are the language, and this is the, you know, how you make your sentences to gain points for yourself, right? So this little piece is increasing, and this little piece is also 1-to-1. Okay, so how do we describe this function? And this is going to be a new function. Okay, we're going to come back to this new function. Okay, sine function where x belongs to this interval. Okay, just remember that we said this before, right? In the future, when you look back, we talk about this before. This piece, right, with all the special points we have done there, right? Remember? Okay, and there's a pi over 6, half, and pi over 4, and so on and so forth, right? Remember those? All right. Clear drawing. Okay, I hope you haven't forgotten, right? So I'm gonna put a few more points here. Okay, I'm gonna put a few more points here. Remember those other points we did, right? Pi over 6. Half. Does that point show up? Yes. the blue point right here, right? And next point, pi over 4, root 2 over 2, that point, one more, pi over 3, there, root 3 over 2. Oops. Root 3 over 2. I have to do that outside, right? Otherwise, it's not going to be the same number. There. So these piece, okay, I'm going to make it larger. I'm going to make it larger. Okay. Make it larger. So this box, this piece of special interest to us. Just, I want you guys to take notes. I want you guys to take notes on that piece. Okay, let's see if I can make it larger. There. That's what I want. Okay, so this piece. Okay, so I'm going to draw that box again. This function, okay, with that box. With that box, this piece. It's a short piece of sine function. Okay, it's a piece of sine function. This piece is of special interest to us. It's increasing, it's 1-to-1, and it's a new function. What I like to emphasize, this is a new function. And this new function is 1-to-1. Okay, sine function, the old one, the sine function is not 1-to-1. Okay, so whenever we refer to sine, we refer to that sine we used to know. But when we talk about this new function, we have to tell the reader, hey, the domain is different. The domain is imposed on. Okay, the domain is imposed on. So sine, this piece, okay, has inverse. I'm going to talk about arcsine from here. Okay, so arcsine is the inverse of this piece. Okay, we'll get to it. Okay, so now we have talked about the description of increasing, decreasing, new function, right? We're going to come back to, right? Next, even function, odd function. Even function, odd function. Okay. I think I probably should make another, I should make another lesson with these topics. Okay, we're going to make another lesson with the topics. But anyway, let's stop here. And I want you to think about it. I want you to think about it. Even function, odd function. What's the definition, right? We talk about even function for opposite input, same output. Okay, for odd function, what happens? Opposite input, opposite output. All right. So review that topics before you watch the next one. Okay. So I will see you guys in the next lesson. Thank you for watching.